All right, in this video's lesson, what we are going to be talking about is the Pythagorean Theorem as well as its converse. You're probably pretty familiar with the Pythagorean Theorem. The converse you might not be as familiar with. So make sure that you're watching the entire video. We're going to be talking about kind of everything else that's going on with the converse. But also it would be a good thing for you to refresh kind of what the Pythagorean Theorem is and kind of how it works. So the Pythagorean Theorem is what's used to find missing sides of a right triangle. And that's a big key, is that it has to be a right triangle. So this doesn't work all of the time, just some of the time. Now, in any right triangle, the square length of the hypotenuse, or the longest side, must be equal to the sum of the squares of the length of the legs, which are the shorter sides. So if you're looking at this in a diagram, and I've got an example for you over there, you've got triangle ABC. Notice that A and B are called the legs. They are the shorter two sides of the triangle, and that C is called the hypotenuse. And so writing this out, this is probably the equation that you're most familiar with, which is that A squared plus B squared must equal C squared. Now, it's important to point out that A and B can kind of be used interchangeably. C has to always be the side which is opposite the right angle. So starting at your right angle and going opposite, that is always going to be the C value. Now, when we talk about Pythagorean Theorem, there are some special types of triangles which are called Pythagorean triples. And so a Pythagorean triple is any time that you have three positive integers which make the Pythagorean Theorem true. As an example of that, 3, 4, 5 is the smallest Pythagorean triple. And so if you take 3 squared plus 4 squared, you actually do get 5 squared. To show you that that works, 3 squared is 9, 4 squared is 16, 5 squared is 25. 9 plus 16 is 25, and 25 does in fact equal 25. All right, so let's take a look at some examples of this, kind of how it works. So our first example, we've got 5 and 12 as our shorter sides, x as the hypotenuse. So when we're setting up our variables, it's important to make sure that that side that's opposite your right angle always has to be C. The other two, you can make A and B, and it really doesn't matter which one you make which. A lot of people like to make the shorter side A and the longer leg B, but it really doesn't matter. All right, so putting that into our formula, we're going to take A, which is 5 squared, and then take B squared, which is 12 squared, and set that equal to C, which is x squared. So then 5 squared is 25, plus 12 squared is 144, is equal to x squared. And then 25 plus 144 is 169. So now to get x by itself, we're going to take the square root of each side. So the square root of 169 is equal to the square root of x squared. In other words, x is going to be equal to 13. Now this is also going to be a special case. Notice that 5, 12, and 13 are all whole numbers. So this would be an example of a Pythagorean triple. All right, let's take a look at another example. So on the next example, again, I always like to start with the side which is opposite the right angle, and so C would be equal to 9. So then I'll let A be 7, and I'll let B be x. So setting up our Pythagorean theorem, we're going to say that A squared, which is 7 squared, plus B squared is x squared, is equal to C squared, which is 9 squared. 7 squared is 49, plus x squared is equal to 9 squared, which is 81. So now let's go ahead and subtract 49 from each side to try solving for x. So that's going to leave us with x squared is equal to 32. So now we'll take square root of each side, so square root of x squared and square root of 32. Square root of x squared is just x. And then this is why we did all that work with simplifying square roots. is let's rewrite the square root of 32 as the square root of 16 and the square root of 2. Where the square root of 16 is 4, square root of 2 we leave alone, so then there is what our missing variable was equal to. Now notice in this case that we do not have all whole numbers, so 7, 9, and 4 square root of 2, because 4 square root of 2 is not a whole number because it has that square root of 2 attached to it, so this is not a Pythagorean triple. All right, let's take a look at a couple more examples of this and we'll see how it works then in context. So our next example, again, opposite the right angle is x, so that's going to be c. I'll then let a be 8 and b be 13. So we're going to take a, which is 8, and square it, b, which is 13, and square it, and c, which is x, and square it. And then I'll go ahead and simplify. So 8 squared is 64, 13 squared is 169, is equal to x squared. Which then 64 plus 169 is 233. And we'll set that equal to x squared. And then we'll take square root of each side. So the square root of 233 is equal to the square root of x squared, which is just x. And in this case, it turns out that the square root of 233 actually cannot be simplified. So that's going to end up being what we leave for our final answer. All right, let's take a look at one last example here. So we've got kind of this triangle. We're looking for x. I'm going to just focus then on this triangle right here, which is a right triangle because notice that you've got the right angle to the right, which means there also has to be a right angle to the left. Now, we don't know what the length of that bottom side or the base is. We do know that the whole length is 22. So if we take half of that, which is 11, that should be the length of the third side. So now let's go ahead and set this one up for Pythagorean theorem. So opposite our right angle is 24, so that's going to be c. And then I'll just let a be 11 and b be x. So then we'll go ahead and set up our Pythagorean theorem. So a squared is 11 squared plus b squared is x squared equals c squared, which is 24 squared. So then simplifying all of that, 11 squared is 121 plus x squared is equal to 24 squared, which is 576. So now let's go ahead and subtract 121 from both sides. We'll get that x squared is equal to 455. And then to get x by itself, just take square root of each side. So x is equal to the square root of 455, which again will not simplify. So that'll be how we'll leave our final answer. Now we didn't talk about it for the last two, but if you notice our final answer was a square root for both of those. And so pretty clearly those are not Pythagorean triples. If you want to write that down, you can. If not, just you can look at them and tell that they're not all whole numbers, so it can't be a Pythagorean triple. All right. For this last example of Pythagorean theorem, before we talk about its converse, we're going to look at it in context. So it tells us that we place a 10-foot ladder against a wall. If the base of the ladder is 3 feet from the wall, how high up the wall does the ladder reach? And it wants us to draw a sketch. So let's go ahead and draw our sketch. So here's the wall, here's the floor, here's our ladder. If you want to just draw a side, you don't have to draw the detail. I'm just doing it for fun. Now, we're going to assume that the wall was built correctly, so we'll assume that it's a right angle there. We know our ladder was 10 feet, and we know that the base of the ladder to the wall is 3 feet. So what we want to know is how far up the wall does it reach? So let's call that x. Once we've got that set up, let's go ahead and set up our Pythagorean theorem now. So opposite our right angle is our c value. So c would have to be 10. And then we can let the other variables a be x, and we'll let b be 3. So now we'll take a, which is x, and square it, plus b, which is 3, and square it. Set that equal to c, which is 10, and square it. So then simplifying that, we have the x squared plus 9 is equal to 100. So now let's go ahead and subtract the 9 from both sides, and we'll get the x squared is equal to 91. So to get x by itself, we'll just take the square root of both sides. So x will be equal to the square root of 91. And then that would normally be how we would leave our final answer. But notice that we are actually in a context. And so it wouldn't make much sense to say the square root of 91 feet. Especially if you were a construction worker and working on this, you're probably not going to know what the square root of 91 feet looks like. But if you put that into a calculator, you'll find out that the square root of 91 is about 9.5. And as a construction worker, you probably have a lot better idea of what 9.5 feet look like as compared to the square root of 91 feet. So whenever you're working on a problem in context, it'll be best to actually put it in the calculator and get a decimal for an approximation. And we'll go ahead and continue rounding to the nearest tenth. Okay, so that's the Pythagorean theorem. Let's go ahead and talk about its converse. So a converse is kind of the statement, but in reverse. So the Pythagorean theorem said that if a, b, c, or if we had a right triangle, then it had to be true that a squared plus b squared equals c squared. The converse says that if c squared equals a squared plus b squared, then the triangle has to be a right triangle. So as an example of that, I've got a triangle over here, where if you take 6 squared plus 8 squared, does that equal 100 squared, or 10 squared? I was already squaring it. Oops. But 6 squared is 36, 8 squared is 64, 10 squared is 100, and then 36 plus 64 is in fact 100, so 100 does equal 100. Now, not every triangle is going to be a right triangle, and so it's important to know kind of when you have either an acute triangle or an obtuse triangle. So if it turns out that c squared is less than a squared plus b squared, then we'll say that the triangle is an acute triangle. As an example of this, 9 squared plus 11 squared, and let me write this kind of in the other direction. So let me go ahead and start with c squared. So c squared is going to be our longest side, which is 11 squared. And I'm going to show that 11 squared is in fact less than 9 squared plus 10 squared. And it shouldn't be too hard to show. 11 squared is 121, 9 squared is 81, 10 squared is 100. And yeah, it should be pretty clear that 121 is less than 181. So it is in fact true that the triangle that we've got here is an acute triangle. Okay. Now, if c squared is more than a squared plus b squared, then triangle ABC is going to be an obtuse triangle. So again, if we let c be the largest side, so 12 squared, we're going to show that that is more than 5 squared plus 8 squared, which 12 squared is 144, 5 squared is 25, 8 squared is 64, and 144 is in fact more than 89. So our triangle in this case would have been an obtuse triangle. Now, the last thing to talk about, and then we'll kind of see how this works with a few examples, is if you want to decide if 3 lengths are possible lengths for a triangle, then the sum of 2 of the sides has to be more than the third side. As an example of how that works, if you have 3, 5, and 7 as the potential side lengths, then if you take 3 plus 5 is 8, 8 is more than 7. So yes, this first example would in fact work as the lengths of a triangle. However, if you take the next example where the shorter 2 sides are 2 and 3, and you always have to add up the shortest 2 sides, 2 plus 3 is 5, and 5 is not more than itself. And so in this case, we are going to not be able to do that. All right, so to take a look at some examples of kind of how this works. Our first example is we've got 3 plus 7, which is 9. And so first off, can they form a triangle? Well, 3 plus 7 is 10. 10 is in fact more than 9. And so yes, they do work to form a triangle. Now to decide if it's acute, right, or obtuse, if we take 3 squared plus 7 squared, that's going to be 9 plus 49, which is going to add up to be 58. 9 squared is 81, so this is less than 9 squared. And so if that's the case, our c squared is more than a squared plus b squared, so this would be an obtuse triangle. All right, for the next one, 20, 21, and 29. 20 plus 21 is 41. That is in fact more than 29. So yes, this will in fact form a triangle. To decide if it is acute, right, or obtuse, if you take 20 squared plus 21 squared, that ends up being 400 plus 441, which is 841. 29 squared is also 441. Because those are equal to each other, we can actually say that this is going to have to be a right triangle. All right. For our next example, we've got 4, 11, and 16. If we take 4 plus 11, that is 15. 15 is not more than 16, so this is not going to be able to form a triangle, so we will not have to answer the second part. For our last triangle, we're going to take 17 plus 17, which is 34. 34 is greater than our third side of 22, so then we are going to be able to do that. All right. Now, let's decide if it's acute, right, or obtuse. So that's going to be if we take 17 squared plus 17 squared, which is going to be 289 plus 289. That adds up to be 408 or 578. Now, 22 squared, which is c squared, is only equal to 484. And so c squared, which is 484, is less than our other two sides squared. So it's less than 578. Because of that, we're going to say that this is an acute triangle. All right, so let's look and see how this works in context. A contractor is pouring the concrete for the foundation of a house and wants to ensure that the corner is a right angle. Notice that the length of the foundation is 10 feet. So we've got our foundation. The length is 10. The width is 9 feet. So here's 9. And our diagonal is 17 feet. So here would be 17. And we want to know, is this angle that I've circled a right angle? Well, let's look and see. What is 9 squared plus 10 squared compared to 17 squared? I'm just going to put a question mark there because we don't know that they are equal. We do want them to be equal if it's a right angle, though. So 9 squared is 81, 10 squared is 100, and 17 squared is going to add up, or multiply, to be 289. 81 plus 100 is 181. That is less than 289. So this would be an obtuse angle. And so what we would have to say is that it is definitely not a right angle. All right, that's all I've got for us in this video. Until next time, have a great rest of your day.